If you ain't in the gate, you're late. Let's roll. It's broken. Other button. I'm hitting the green button. Oh, there we go. See, somebody put me in charge. That was dangerous. All right. So a bit about my background. Heavy DOD, heavy counter intel, MI, worked with the U.S. government for, 18 years. I feel old. I've worked with almost every intelligence agency that exists in the U.S., most that you know of, some of them that you don't know exist. A lot of fun there. I've worked a lot with intel campaigns, with FBI, AFOSI. I helped build the Mark Center, so that's where all the intelligence agencies aggregate their data for the Pentagon. To help tear down the Sky 7 for the NSA, build up Fort Meade for the new headquarters location. I worked all across nuclear systems. I was a security lead for Savannah River Site Nuclear. That's where the nuclear bombs are manufactured for the U.S. government, as well as most of our European partners. This thing has a lot of feedback. I can hear me. It's weird. I've done a lot of campaigns outside of work. Had a lot of fun doing that with doing nation-state-based attacks against foreign assets. I've successfully smoked the Chinese, the Russians, and the North Koreans so far. The Iranians are on my next list. That's going to be fun. They've made some interesting decisions lately. So response incoming and inbound. So we're talking about CNO. CNO, CNE, they're used interchangeably. I don't agree with it because one says exploitation, one says operations. Realistically, they're the same thing. And they all have three things in common that are very, very important. What is your purpose? What is your implementation? And what is your capability? It doesn't matter if you have the best hacking tools in existence and the most badass infrastructure ever. If you have no purpose, you are lost. You will never be able to get anywhere or do anything. Just like with any of the other characteristics. If you have the greatest mission since sliced bread and your Betty White is your boss, that's awesome. And you have the best exploits ever. If your infrastructure can't handle the throughput and you can only pop one box a day, it doesn't matter. You're dead in the water. So, how do you declare purpose? You have to know what you're there for. Whether it's for military purposes, for kinetic or non-kinetic reasons. Why am I here? What am I doing? Am I spying on people? Am I creating a long-term presence, a short-term presence? Am I looking for a particular individual or asset? What am I hunting for? Or am I here to put warheads on foreheads? And I'm looking for somebody for a very simple ITK model. Identify, target, divide by 0. So, coming into weapon systems, you have to understand what your system is because you have to know what you're building. What are you building it for? What are you targeting? Systems that are built for something like a land-based material is not the same as something built for something on the water. You're going to have a very bad time if you build a system to target airplanes and you try to use it against ships. So there's a classification model that I came up with that I've been teaching. I find it highly effective. Cyber, land, air, space, and sea. The class system. Just like with characters, everyone's good at something and they suck at everything else. Now, when you're looking at the classification of a tool, that gets you into a very different model. Now you're having to actually assess your tool. What can it do? How well can it do it? What is it built for? What stage is it at? Where are we headed? So you've got concept code, defunct code. You've got nuisance code, malicious destructive, non-lethal, malicious destructive, lethal. And then you've got a series of classifications of systems that are tiered on the subsystem level before them. So you've got systems with multiple 5s and systems with multiple 6 with large-scale capabilities for collaboration and integrations. So this is when you're talking about weapon systems that can talk from my government to your government, and we're collectively targeting the annihilation of a foreign entity or institution or maybe even country. And so we're talking about the full-scale annihilation because we may have a weapon system that's capable of targeting all of your waste management systems, but we also want to knock out your ability to provide water. And so the UK may have a weapon system designed for wiping out the water systems, but they don't have exploits for anything else. We combine those through collaborative efforts, collaborative coordinated attacks, and boom, No more Moscow. So when you start looking at things like these levels of systems, you start integrating these, you're going to start to find certain things, certain characteristics. Developments of certain tools for profiling will have certain characteristics, certain capabilities, certain capacities, certain methodologies. You can start to use those to do everything from profile the code to profiling the developer. And so we'll skip over these because they're relatively basic, and we'll talk about those later. But realistically, the effort that you want to capture from that is that each one of them, up to level 6 and 7, you're going to relatively see either within your standard commercial space, or you're going to see within a very limited space of professional operators, typically up to 3 and 4, and maybe even in some cases 5. So you start to see more dangerous tools that can be extremely dangerous if leveraged with the right people. I liken it to, Anakin with a lightsaber. You give a rookie a lightsaber, you have a really cool lighter. You give Anakin a lightsaber, you've got the world's greatest abortion clinic. So run it with you may. So when you start talking about implementations, you start talking about constructs. You start talking about constructs, you have to understand what you have in play. What is the design? What is the data? What is the outcome that you want? How are you developing it? How are you building it? How are you managing that team? You have a team. You're building something incredibly elaborate. Either that or you're working with someone psychotic like me that's done a crazy career and has worked on everything. So you want to understand what you're looking at. You have to understand how you're looking at it. Network, systems, data, in that order. Because it doesn't matter if you have the best systems and the best data. If it can't communicate, it fails. So you have to have the best systems, because if the systems can't aggregate that data properly, store that data properly, and structure that data properly, you're not going to be able to access your data effectively. That's why the order exists. You have internal data, you have external data, and then you have the data structure itself. This point here, extremely important for your data. You have to manage your data and manage it well. If you don't structure your data, you're in for a shit show, because you're going to pull your data and you've got gobbledygook, and you're going to get back unknown or unexpected or undiscernible data results. And then you're going to have to modify all the stages thereafter just to deal with the mistake you made the stage before. Architect it well, then it will be structured well. Therefore, it can be analyzed well and stored well within libraries so that it may be indexed and mapped effectively, so that you can then tie it into the next core component, which is development. Now that I have my infrastructure, now that I have my enterprise, my networks are in place, my systems are in place, my data is designed well. It is well structured, it is well stored, it is well understood, and it is well mapped. So then I can build custom systems to interface with that, starting with the back end. Your back end will interface with your data structure, which runs off the back plane of your design. And then with that, then you can build your UI. Most people say, well, we want to build the user experience first. No. Most users are idiots. What you want is a UI that will give them a structure to look at. And inside of that structure, you can place a nav bar, a sidebar, a foot bar. You can put data fields A, B, C, and D. And then the user can test that, and then you can get into TDD and user feedback-based development through UX. Because then you have something that works. And then they can easily say, well, the data structure is great. I love the way that it's mapped out. I like the current systems, but the UI component for this space, I don't like. Put that over here. Okay, cool. Shift that down here. That's a modification for CSS, JavaScript, Sass. Not a big deal. Minor changes, rapid development, rapid deployment, speed of operations. CNO is about speed of operations. If I have to spend 15 days on the damn network looking for things to deal with a small issue for a minor UI component, it's going to take me forever to get you the tool that you want, versus giving you something and getting immediate direct feedback and driving that immediately forward. So we're not going to spend too much time on those, but we will spend a lot of time on this. Those were design questions we just covered. This is how you want to start to map out something. This is known as the level 1 DFD, data flow diagram. This is how things will communicate with one another. Documentation is typically the most ignored and abused thing in an enterprise. oftentimes neglected to catastrophic results. You need to understand what you're touching. When you start talking cyber weapons and CNO operations, you're not playing with something like Red Canary anymore. You're not playing with a toy. You're playing with something capable of wiping out a country. You need to understand what you're putting your hands on and what you're putting your hands around. So understanding that with DFDs, they go from level 1 to level 4. And each DFD diagram has a particular purpose. This one is level 1. It shows you how everything connects at a very top level basis. It goes from the framework to the Postgres system to the async process to a predefined function, typically through a microservice, to a backend systems call that it can communicate to the backend systems of various other containers to communicate with other tool systems that can interface, pull data back in, and inject that into other processes so that you could do something like an adversarial query from your UI to trigger an API request to launch an attack. But you can do that as a collaborative effort, as a team of individuals. You can also do RBAC-based implementations. So it's, we'll say, this cool dude up here has the ability to say, you know what? I'm going to allow that call. But then she says, well, I'm in compliance. And I don't think you should nuke the UK because turtles. Well, he has the gun, but she's got the ammo. If you can't lock and load, you've got a good control system. You always want a separation of duties, unless you just absolutely trust the people you're operating with, or you're operating in a private sector environment, and you're a very small team there for very good reasons. Now, when you're looking at the external WAN infrastructure, you start to look at how do you flow the traffic itself. This is where the network component comes in. Most mistakes are made here, where they'll have the forward proxy that routes to internal traffic that routes to the enterprise infrastructure. They fail to implement this stage here. It's a critical stage. The reasoning why is, well, what if I don't want a sister agency to have direct access to my forward proxy information? What if I don't want them to know how I'm being accessed for my CNO, CNE operations? What if I have a vendor partner and I don't want them to know? What if I have my data feeding back from all of my C2 systems? If I have an edge proxy versus my forward proxy direct, I can send it to my edge proxy, and at any time I believe it's compromised, I just cut it off. Nothing gets compromised. I just cut it off. And I still have my forward proxy, which I can change at any time, which protects my reverse proxy and everything else. That way I can avoid a full systems compromise and all kinds of other cascading failures because of that. Then we get into the UI. How do we make her pretty? Well, you can't just slap lipstick on her. UIs don't work that way. You've got core functionality. Core functionality is based on your purpose. What does it do? What is it supposed to do? What is it supposed to do well? Then based on that, you will immediately know, should I make it a web application or a standard mobile application? Should I make it for Android or iOS? Well, I don't know. Who do I trust more? I definitely wouldn't say these people because they actively monitor your device. You want a CNO operation on a mobile device? iOS? You out your damn mind. If you're going to do anything, put it on an Android. Personally, I'd say BlackBerry, but nobody uses that. Then on the web side, you're almost always going to be services-based. Can anybody tell me why? No takers? Cowards. It's got to be somebody. Take a guess. Why would you always run services? Only services-based. Wow. You want to run services-based specifically because of the fact that when you're looking at large-scale operations, you need large-scale throughput. You can have large-scale throughput of services on monolithic applications. However, if all your services are on one monolithic application, you're going to experience a failure. What happens if they compromise that one service? They've compromised everything. The entire thing is popped. If they pop one internal service, you could chop off that arm. Everything else is still contained. You can have various services. I can run a service that's external to my proxy. I can have that as a data access service to where I have a sister agency who I do want to share data with. I can run that service as an aggregate service of all of my data operations, but not give them access to any of my TTPs or even my internal enterprise. I can share data without sharing technology. Very important. Then you can get into the services question. Do we want to run monolithic or micro? And that comes through throughput, and that's based on purpose. If I build a tool that's heavy for recon, well, what am I reconning? Am I reconning a very small group of extremely radical individuals? Well, then I don't need a huge system. I'm not going to need a Kafka-level scalable operation. I could do that just fine with some Postgres databases. But what if I want to monitor multiple groups of unknown sizes? We start talking intelligence agencies. Microservices is a good way to go. Now, microservices could mean a lot of things. That could mean running literally services code. That could just be a Python function floating in oblivion on what they say is a serverless environment, which is a Linux box that's been stripped down. There's never such thing as a purely serverless environment. You could have a microservice, which is a container that runs a very particular Flask application that does a very particular thing. You could have that running a full-on API backend where that API service communicates to another application or another service or web services or portals, period. You can have an entire different UI that interacts with the data completely differently. You can segregate the data on not only the user permissions level, but the actual data model itself. You can take the data and carve that data up and say, based on this data point for this data model, I want that model for these fields available to these operators, but not the other data fields to the other operators. You're segregating your data itself and not just the access. It's not just, oh, well, I'm admin, I have access to everything. No, you're an admin. The only thing you can see is infrastructure. Now, when we get past the campaigns, we start talking about the intel. Everything about CNO and CNE is driven by intel. That gets down to what is hacking versus what is intelligence. Because operations and operationally, they are not the same. They do not function the same. The skill sets are not the same. If you've ever met somebody in a hacking conference, which is 100% of the population, somebody that's a red team operator is not on par with somebody who does social engineering professionally. They have a very different tool set, tool suite. He's like, nah, I do. There's a handful of people that are incredibly good. Joe Gray is one of them. He scares the shit out of me, and he's an awesome dude. But there are very few and far between that I've met that have the skill sets to cross both lanes. And when they do, they're typically monsters. Now, when you're looking at intel, you have to be able to segregate that intel because intel is not created equal. Open source data feeds are not the same as having direct access to the Department of Labor and the DMV. But then you've also got other systems where we're looking at things for data. When you're looking at the data and the data structure itself, you're looking at data versus data flow. Because it's one thing if I can make a database call. It's another thing if I'm receiving real-time data from another agency, another institution, an RSS feed, something on an XML format that's being fed to me or through a JSON, through a REST API, or some other API protocol like Fast API. When I'm receiving data feeds in real time, I have to respond to those differently because breakage is very real. Your network can go down for a second, and that 1 second is measured in milliseconds to a computer system, is measured in nanoseconds to a CPU. And so that one could be megabytes of data. Megabytes of data, just gone. Megabytes doesn't sound like a lot until you realize that text-based data streams are in the bytes level. You could have lost an entire operational capacity, an entire new OU that you completely missed. One blip, that's it. And so you have to respond differently. That's when you start to design differently. Very important. That's when you start to look at how do I cache my incoming data? How did I certify that my data feed coming in is accurate? Am I replicating across data structures from point A to point B? Does their database match my database? How do we sync up databases without giving you access to all the database? How do I do a partial table comparison? How do I compare just my one table to your one table without comparing the entire database? That's when you start to get into the really intricate levels of data management and data operations, which becomes very important very quickly. Now, when you start looking at intelligence, you have to understand the types of intelligence, because some intelligence is very passive. It doesn't require a response. Some intelligence is hyperactive, which means if you don't make a split-second decision, somebody will die. They are going to die. When you start talking about that type of intelligence, you're looking at counterintelligence, military intelligence, typically. Most OSINT data doesn't carry that cost burden. So you have to have a weighted approach to your intelligence analysis. What do you give priority? How do you give priority? Well, that's based on purpose. If your purpose is counterintelligence, you may have to make the split-second decision of let an asset die. That's a hard call to make. Can you imagine that, sitting in a command operation center of some kind, sitting somewhere halfway across God's green earth, knowing you can flip a switch in a second and turn somebody into space dust? But in doing so, you compromise a mission. So you have to let a known asset die so that you can maintain access and persistence. These are some of the hard challenges that you have to make, that you have to address, that you have to overcome when you're operating at these capacities. You're not playing games anymore. Now you're dealing in human lives. Now, the multiple types of business intelligence, well, that crosses an interesting threshold, because we are at a time, space of going kinetic, and we are going to rock the boat. Some people have already been approved for hacking back. Some countries, some organizations, some states are still considering it. But very quickly, this type of intelligence is going to be applying these types of intelligence to then be able to respond to other forms of intelligence, at least from in the US perspective. Some other countries are considering it, some other countries are not. It really depends on what you're doing, where you're at, what is the business prerogative, what is the business assessment, what is the risk tolerance, and more importantly, what is the cost? If you're looking to accept the liability, for instance, of erasing a human life, if your company takes an average of a 3 to 8% hit to its stock market price, and you're worth $400 billion, cost of a human life is going to be somewhere between 2 and 10 million. Shake that tree all day. But then what's the legal ramifications? Well, it depends. What country are they in? Do you think the U.S. is ever going to honor a Russian murder extradition order? These are questions we have to ask. They're ethical questions. They're legal questions, moral questions. They're hard questions to answer. We don't know. It depends on the institutions. These are some of the examples. Some of these things look like trending data pieces for business. We could be seeing Google hacks a 15-year-old in England 5 years from now, 10 years from now. Landscape is evolving quickly. We're seeing certain data sets in cyber. There's another good one here. This one I pulled directly off of one of the companies that I'm actively analyzing. This belongs to Wagner, or PMC Wagner Group. And this is one of their recruitment ads, which is paying a tanker about $3,200 a month. If you want to go to war in Ukraine. Good luck with that, Abrams. And then these are some hybrids. This is what it looks like when you have an integration of hybrid data. This was when the Ukrainian IT army hacked the PMC Wagner site. When you integrate things like human int, analyzing the users, military int, an operational capacity to knock out the recruiting capabilities, and then counterintelligence, because they are actively analyzing one of their major competitors, PMC Wagner, who is actively campaigning to recruit staff members to go directly to war in the Ukraine. And then they took the bodies of all the dead Russians that they'd killed recently, hacked their website, and put some new graphics on there. Help with recruiting. Now, when you start talking intel is very important. You have to understand your data. You have to master your data. You need to understand what is its value. I created a model for that. You've got 4 very big components. My personal favorites: fidelity. How much do you trust the data? It doesn't matter where it came from if you don't trust it. You've got to have integrity, which means it's always going to be on point, even if it's information you don't want to hear. Nobody wants to hear about layoffs. But if you tell people about layoffs 100% of the time, when you say there's either going to be layoffs or not going to be layoffs, you're far more likely to trust the source, especially if they've always told you the truth. That's why Google is facing a crisis currently. Quality. If the data isn't structured well, if the information isn't structured well, if it leaves out key details, key components, the data is low quality, which means it's not viable. It's not trustworthy because it's not viable, not because you don't trust the source. You can't act on data that's incomplete, at least not to a good event, not to a good outcome. And then age. If I tell you there was a warship in the Cayman Islands in 1942, fantastic. No one gives a shit. If I tell you there's 6 Russian carriers outside right now, well, holy shit, let's go take some pictures. Like, that's age. Look, ooh, hell yeah, let's go see. Maybe we'll throw some marks. Now, data structure versus data modeling, they are not the same. This is a mistake that a lot of people make, and it personally frustrates the shit out of me as somebody who has to clean up the mess. And the reason why I say that is when you come up behind somebody who has structured the data versus someone who has modeled the data is modeled. If it is modeled incorrectly, it doesn't matter if my data systems are built well because your data is not formed properly. If I use an elastic system, something that everybody in here is probably relatively familiar with, or Oracle or Postgres, a database, and I have data tables, and you're injecting user data into my cars table, it's going to be really interesting when I pull up Mr. Toyota because his last name is Prius. That's going to be a fun time. Now, when you start looking at these things and you start analyzing the data structure, you start looking at data keys and key value pairs, you start to assess these things, and you're looking at them from a perspective of what kind of data fields. All right, well, now we're getting into the data structure itself. Structure, model. This is how I have modeled it. My site key value pair, fidelity score, integrity score, quality score, age score. Who did it come from? Country of origin, user base, target system, acquisition period. What is the target value? You can use a target value sector inside of your scoring model just for analyzing where you want to put military assets. And you can search that by an M or a B. Can I do millions of dollars in damage or billions of dollars in damage? Because if I can crash one Reaper drone into one of your battleships and sink it, I'm going to spend about $400,000 to wipe out something that costs about $4 billion. I will spend that dollary-do every day because that is some serious collateral damage. Now, when you start looking at event sourcings, you're starting to look at the separation here. You've got artifact source, you got event source, you got artifact event. You can have any number of columns. You can have any number of indexes. You can have any number of data structures for those, including TDMA-based. You can have them in CDMA-based because you can segregate them by the cell phones that you're hacking. And each one can have a significant identifier, such as a UUID or an IMEI number or a phone number. And you're aggregating all of that data based on the individual indicator. And then you can filter for those. You can have aggregated structured layers of tiers of data set to where you can aggregate something as simple as to who has the same applications installed on the same phones inside my Elastic system on this side of the country in the past 46 to 92 hours. You can get that specific. Because if they're operating, leveraging the same communications devices and the same communication mediums, and they're operating on the same 3 or 4 applications, and you can't capture all the information for them and identify them as a warfighter, you can identify them based on the applications that they're sharing in common. Because if they're sharing 3 and 4 and 5 and 6 applications, those applications are doing the same characteristical behaviors. They're doing DNS callouts. They're doing IP communications. They're leveraging specific protocols. All of these things you can track as metrics, and you can correlate those inside of a system, any kind of system, many types of systems. My personal favorite is Apache Spark. It is a beautiful system for aggregating all of your wonderful data into one place and querying it. Now, once you have the data, these two pieces get screwed up a lot. You normalize first. You transform second. You have to have a format. It doesn't matter if it's 100 columns, 1,000 columns, 1,000,000 columns, and they could all be blank, except for the ones that you need. And then you can transform that into that normalized data structure and aggregate the data quickly. And it looks something like this. It could come in as gobbledygook. Pieces completely missing. And then you could say, well, I don't have 2 and 3, or 4 and 5, or 1 and 2, but I do have 1, 2, 3, 4, and 5 collectively. And I can aggregate all that data into a data store, capture that data, aggregate that data after I've normalized the data, and then transform that data into one useful, user-friendly, viable data set where I can track down and trace down all the way down to any of those data columns, to any of the devices, to any of the locations at any point in time, any period of time, with any application at any given point. I can hunt you down and put warheads to foreheads. Now, data is not created equal. It's weighted. How do you weight it? Well, we've already had a pretty good conversation about that. What is the purpose? The objective? How is it relevant? What is its weighting score? That aggregate number allows you to say, well, if I've got 3 different phone calls, 4 different phone calls, 5,000 different phone calls, like in natural disasters, for instance, I've got 5,000 different phone calls about people being hurt. Well, how do I weight that score? Well, which ones were, oh, I've got a cut to half my arm is missing. Well, what are they going to be the goals of? Are we looking for disaster recovery, preservation of life? Are we looking at a mixture? Are we looking at causing the missing arms? If we've got 15,000 phone calls and 15,000 tips and there's a person that we're looking for, well, how do we weight that? Well, who did it come from? The fidelity score. If it came from, New York Police Department, I'm far more likely to trust that versus Granny Smith. Not that there's anything wrong with Granny, but we need to weight that somehow because we're more likely to capture somebody if we do. Now, this is a weighting score model that I use. You can create up any one that you want. It works well for me. Higher the score, more likely it is to be accurate. Lower the score, more likely you are to be turned into space dust. Now, that's how a data flow diagram can look in any average environment. It works very well. Data sources, data byproducts, data direct, into your storage. Storage into processing, processing into dedupe. You want to deduplicate the data, get rid of it because data is expensive to store. It also impacts performance, accept, reject, kick it into the next pipelines, whatever those pipelines are. Now, we're talking about capabilities and personnel. We're getting into the personnel, infrastructure, technology. What can it do? How can it do it? How fast can it push the data? If you can't push data well, you're screwed, especially in real-time operations. You have to be able to move and move fast. Personnel, they have to have skill sets. You have to understand your team. This is the most important thing from the talk. If you take nothing else, go back to your workspace, build a skill matrices, find out what everybody is, what everybody does, and most importantly, what everybody enjoys doing and what they're good at. You'd be amazed to find out the skill sets that you're completely overlooking because you've never built a skill matrices. You don't know what you're capable of if you don't know what you're capable of because you never asked. That's the number one mistake I found in most teams. Now, vendor capabilities and capacities, you're married to the vendor. That comes with its own problems. Your data structure, data modeling, data ETL, you have to be able to move data. And then capabilities comes to your technology. If you can't push capabilities, you can buy them. And I promise you, you can buy them. There's a list. Now, you have to understand your personnel and what level they're at. They're not just, oh, I do Python code. It's, oh, well, I've written one Python script one time 10 years ago versus I'm a core contributor to the Django and Python project, specifically for back-end systems with UIs with my Django Geo project. I actively contribute. It could be argued I'm in the 4 to 5 area. People who have only ever written one Python script ever, probably in the tier 1. Now, it answers questions. How? Analysts, they're juniors, they're rookies. They can't do much. They can click a button, They're the monkeys in the sock. They hit the button, they smash the button, they make the thing go bling. Now, engineers, this is where most people live once you've hit senior, engineer level. You can do most engineering things. You can do most things, manage most systems, operate most capabilities on a localized basis with minimal interaction, minimal assistance, minimal capabilities, minimal vendors. You can do the what, but you can't do the where. You don't know why it's there. You just know that you run the blue coat. You know that it moves the traffic. You don't know why you put the blue coat there to modify the behavior of the applications that are 5 stacks down, because you just run the blue coat. You don't ask questions. Most people never see tier 3 truly because they don't understand the where. They manage a lot of people at architect level. You have to understand a lot of things about the environment and the ecosystem. Most people never reach that. Now, developer, you're starting to answer the why question at a more intimate level. You know not only where it's at and why it's there, but you understand the why it was made, why it was put in there. Why do we rate limit inside of the proxy? Why did we choose this DLL library versus that DLL library? But then you get to the expert level, and you can say, we did it in this way, specifically because of these performance metrics. We didn't just say we're going to go with that DLL versus this DLL. It's when you plug this bad boy into an ARM64 processor with 28 cores, 128 gigs of RAM, 15 NVMe drives running in a RAID 0 across a parallel processing system, across a Postgres XL database for distributed data systems, you're going to see a 0.67215 metric improvement per transaction speed of 4K or less. On a 26 to 128 megabyte transaction, you're going to see a 1.7 millisecond improvement. Those are the levels of details that they can give you, and why. The in what way. Very important. Now, last but not least, you have to have the skills to pay the bills. Networking, systems, automations. You have to have these. If you can't do them, you are up shit creek without a paddle. There are holes in the boat and the bears on the coastline, and it is dinner time. You are donezo. You will not make it. Probability of success is negative. The nice to haves, you've built custom tools. You've got red teaming experience, penetration testing, and operator. They are not the same. Separate the mindset. They do not behave the same. They do not test the same. They do not play the same. And they definitely don't play by the same rules. Architecting experience, especially for SOCs, Intel operations, and enterprises. If you have played with systems, you understand why they work, where they work. That helps you to do this. You can build tools because you understand what to target, how to target it, in what way to target it, what makes it functional, what makes it good, and what makes it bad. Because you can beat up the bad all day. Now, the highly desired skill sets that are going to make you the $300,000, $400,000, $500,000 are these. C, C++, assembly, especially with Intel-based processors. AMD is shifting in because they're now a better price point, especially for cloud. Malware development of any kind, especially anything that's polymorphic and multipartite, especially if you can combine the two. Obfuscation services for detection avoidance. Huge, huge money right there. You can do advanced APT training for companies and organizations like Forge and other institutions like that with the NSA and other foreign assets like 8200, 74455. If you can take that one, raise your hand. Well, no, what is snitch on? That's the Russians. And then you can do things like exploit development. This is where a lot of exploit developers specialize. I personally don't agree with that mindset, but some people do. Mobile is a hot market, especially for nation state. iOS is huge in the States. Android is God mode on a global level because there are far more Androids than Apples. I'm just saying. Are your base are belong to me. Desktop has gone the way of the wayward side. It's coming back because people are moving towards leveraging computers the size of phones. And a lot of desktop applications are making their way over to phones because they now have the computational capacities to handle it. Application pen testing, that's a hit or miss. It depends on what you're targeting. Something's big, something's small. Browsers are huge. And then last but not least, for nation states, if they want to cause large-scale destruction, ICS and SCADA systems, power generation, waste management, water purification, water processing, anything that does logistics and transport, all those things are huge. Now, build versus buy. Do you build it? Do you buy it? It depends. What do you want to do? That's a pretty easy question. It's got the pros and its cons. And then you've got your vendors, who to shop with. You can get pretty much anything you want from these guys for a price. Any questions? Where do you hide? Oh, I'm sorry, sir. People have tried that. We found them in the middle of the desert with $1 million in cash in a hole 20 plus feet down. You can't hide. That's not an option. What we got? Come on. People got questions. How do you build it? How do you hack an iPhone? Can someone break into this Facebook account? Come on, there's something. How do you hack an iPhone? You typically target one of the services running on it. Anything that can be routed through any of the core services of the provider are typically a good target. Browser, SMS services, email, authentication. A lot of the iCloud services are targetable. You're going to have more visibility for development on Android than you are on iOS because they obfuscate a lot of things for the protection of the operating system. But you can also get services that allow you to replicate an iOS device that bypasses those protections from certain vendors, which null and voids that protection, but you got to have some serious cash to buy that. What's up?
Sorry. You mentioned using skilled matrices for
Yes.
teams.
Yes.
Now, my question is, have you ever had or been in a circumstance where that process might have maybe opened a can of worms or backfired in some negative?
Oh yeah, people lie all the time.
But not only lying, consider like a case where someone's role is this, but they're very good at XYZ, and you say, what do you want to do with this?
Oh, that's fantastic. Transfer them over.
Yeah.
Well, don't waste human capital. Your people are your best, your greatest assets. If they've got skill sets and they're in a specific role, I love these. These are my favorite. Where I'll get a staff member like, we'll say her, because she smiles a lot. And she's like, I want to learn fibers. And she's like an analyst or something over in like billing. Well, fantastic. I know that this guy's got all the sliced bread on that skill set. What I'll do is I'll take her, pair her up with him, and bam, I've got a partnered pairing program for mentor protege. And I'll take her skill sets and level them up to his because he may have an interest in management. He may want his job. And we say, okay, well, he's going to retire in 5 minutes because he looks exhausted. And then he's going to take his job and she's already ready to go. I don't have to hire out and pay a staffing agency 38%. I actually just saved a shitload of money by doing it. And it's the easiest cost justification since free money.
So you just try to balance out the penalty.
Yeah, absolutely. Train them up. You always want to train up. The worst mistake you could ever make, not just in CNO and CNE, and I wish people would really take this seriously for a moment. Just level with me. If you don't train your people, you will train your people anyways. What you'll train them in is you'll train them to leave. And that will be the most expensive mistake you'll make because all the money you've poured into them all the way up to that point, 86th, a year, 2 years, 3 years, 5 years, gone. If you don't invest in your people, somebody else will. So you can pay the bill now or you can pay the bill later, but you will pay, period. There is no escaping that. That is a reality of our industry, especially with the current situation, current climate, current hyper availability of roles, hyper role compression. All these characteristics have stacked up to the ultimate disaster in terms of staffing. You are facing an apocalypse. If you don't train your people, you will be annihilated as a team. And I've seen it happen time and time and time again, where people have lost 5, 6, 7, 8 members, 50, 60, 70, 80% of their teams because they refuse to invest in them and train. Something as cost-effective as Udemy, which I personally use, is a phenomenal training source. You're talking $10, $30, sometimes $100 for incredible content, 140, 150, 200 hours of training content with study guides, practice guides, sample code. You can't beat it. So make the minor adjustment now or make a major adjustment later. What you got? Oh, was that too serial? Did I hit a nerve? My bad. Management's like, oh shit, I don't like this guy anymore. No other questions? Oh, you got a hand up. You're raising a hand. Just speak up. Oh, we got a mic. Oh, okay. We're playing past the mic.
Really weird question. Pretty abstract, but could you see Cayman in any way, shape, or form a situation where we might become a target?
Oh, absolutely. You have some of the biggest banks in the world here. They have a small footprint, but they have a huge presence, if you understand what I'm saying.
Pretty much it.
Yeah, very big target. And that's actually one of the reasons why I came here, is it's in the Cayman's best interest to build a very big stick. Because if you have a very big, scary stick, people will be a lot less likely to play fuck around and find out. A fuck around and find out? Oh, absolutely. Hang on. So you've got 0, and the more you fuck around, the more you find out. That's relative to capability, and it peaks. After you start putting warheads on foreheads, it kind of levels out. Like, you can't do anything more kinetic than deleting somebody's house. Now, whether you actually hit the house while they're in it is completely irrelevant. And all you do is send a little love note. Be like, seized by the Cayman government. It sends a very clear message. You hit our bank. That's you subtly saying, we know you hit our bank. We know it was you. We used human intelligence, cross-collaborated with foreign governments, confirmed that it was you, and then we turned your house into space dust. Do you think that person's very likely to hit another bank here again? You hit enough people and their houses or their cars, or maybe you just send them one of those, they got that mail order service where it's a big box of shit. It's just like the worst smell ever. You just send them one of those because that says, we know where you're at. We know you're there. We know it was you. So here's a little love note about all your shit. You can have your bullshit back. That will put the fear of God into somebody. And I guarantee you that will change a lot of little singing canaries. And they'll sing a very different tune. They might become white hats a lot faster than they expected. Just saying. Does that help with the fuck around and find out chart? Yeah.
Organizers asked that we clear the room after this. So thank you very much. I think you gave us a lot to think about in a very interesting